So let us continue to do the problems based on the electric potential, electrostatic potential energy. Okay. Let us start with a simple question. A proton and alpha particle, a proton and alpha particle start from rest in the uniform electric field. Start from rest in the uniform electric field. Find the ratio of their times of flights. Find the ratio of their times of flights to travel the same distance. To travel the same distance. They are starting from rest. So the distance covered is S is equal to half AT square, assuming that they are uniformly accelerated. So T is equal to root of 2S by A. A is equal to F by M is equal to EQ by M is equal to VQ by D into M. Same uniform field means E and V by D, whatever format you take, it remains same. So A varies directly as Q by M. Same question can be given in terms of potential difference also. That's why collectively I'm giving you the concept. Therefore, T
Good morning, sir.
Good morning. Tp by T alpha. It is root of A alpha by AP. So it is Q alpha by QP into MP by M alpha. Q alpha 2E, QPE, MP MH, M alpha 4MH. So it is 1 is to root 2. That's all. Another one. An oil drop with a charge Q is held in between.
Sir, can you repeat once again?
An oil drop with a charge Q is held stationary. Is held stationary between two fixed plates. Between two fixed plates with a potential difference of 2400 volts. With a potential difference of 2400 volts. Given the radius of the oil drop is given the radius of oil drop is 2 millimeters. What should be the charge on another oil drop of radius equals to half of the first one, which is held stationary between the same two plates, with a potential difference of 600 volts. With a potential difference of 600 volts. So here no other forces are considered. Upward force can be assumed to be the electrostatic force, and downward force is the weight, that is the gravitational force. So that's how it is in equilibrium. So it is EQ is equal to V by D into Q is equal to mg. That is Q is equal to D by V into 4 by 3 pi r cube rho g, rho for density, V for volume, because mass is equal to volume into density. So they're all constants. Therefore, Q2 by Q1 is V1 by V2 into R2 by R1 whole cube. So we'll get Q2 is equal to Q into 2400 by 600, that becomes 4. R2 by R1, 1 by 8. So it should be Q by 2. Simple questions. Finished?
So 1 minute. Completed, sir.
Okay. A sphere of 10 centimeters radius has a uniform charge density of 8.85 into 10 to the power of minus 8 coulomb meter to the power of minus 2. Find the electric potential. Find the electric potential at number 1, the center. Second, at a distance. Five centimeters from the center. Third, on the surface. Fourth, at x is equal to 20 centimeters. If the given sphere is, A, conducting, B, dielectric. So let us assume that first it is conducting sphere. Then V naught is 9 into 10 to the power of 9 into Q by R. So this is E into R, means sigma R by epsilon 0 is equal to sigma by epsilon. So V naught will be sigma 8.85 into 10 to the power of minus 8 into 10 to the power of minus 1 by 8.85 into 10 to the power of minus 12 epsilon. Epsilon 0 for vacuum. So it is 1000 volts. Potential at the center 1000 volts. Potential at any point, internal point P1 is also 1000. And V by V naught is Kepler by X, because V is equal to 9 into 10 to the power of 9 into Q by X, V naught 9 into 10 to the power of 9 Q by R. So ratio R by X implies V is equal to, it is V naught by 2 here, because R is 10, X is 20. So we'll get V naught by 2, therefore 500 volts. Even graphically also they can ask, they can give you the diagram. So this is say 1000, they will give. $500 volts. Ten centimeters, 20 centimeters. That way also they can give you the graph. This is by assuming that the given sphere is a conducting sphere. For a dielectric, on the surface it is same. So if it's a dielectric spherical charge distribution, then VC, already I gave you the relation 3 by 2 V naught. Do you remember?
Yes, sir.
Yeah, if it is given directly, of course, you have to do the problem. That formula you have to substitute and simplify. So 3 by 2 into Q by 4 pi epsilon 0 R. Then it is 3 by 2 into 1000. So it is, I think, 1500 volts. What about this? V in 9 into 10 to the power of 9 into Q into X by R square. Am I right? Correct? Huh?
Yes, sir.
So it will be V naught into X by R. V naught into X by R. External point, of course, same formula. Only values at center and at an internal point will be different. Okay.
Sir,
Ah,
that sphere is the charge is present only on the outside, no, sir.
for a conductor. For a dielectric, charge is present everywhere. It's not mentioned that charge is present only on the surface. I just said for a sphere of radius, this is the charge density.
Okay, sir.
Hmm. Completed, huh?
Yes, sir.
Next. The electric potential as a function of distance is given by five plus 4x square. 5 plus 4x square. Find the force on a negative charge of 2 microcoulombs placed at x is equal to 0.5 meters. Find the force on a negative charge of 2 microcoulombs at x is equal to 0.5 meters. So to find force, the formula is EQ, and E can be, of course, minus dV by dx. Therefore, it is minus 8x. That so 82.5 minus 4 Newton Coulomb inverse. And F is equal to EQ. So minus 4 into minus 2. Ten to the power of minus 6. So 8 into 10 to the power of minus 6 newtons. That's all. Next, the potential as a function of distance. The potential as a function of distance is given find the electric field at x is equal to 5 meters. Find the electric field at x is equal to 5 meters. So if you see this graph, it is OABC and x is equal to 5 meters is in between B and C. Therefore, E is equal to minus dV by dx. So it is V2 minus V1 by x2 minus x1, of course minus. So minus of 0 minus 5 by 6 minus 4. So it is 5 by 2, 2.5 Newton Coulomb inverse. Another simple question. A uniform electric field of 10 Newton Coulomb inverse prevails in a given region. Prevails in a given region
Sir, prevails in a
given region prevails in a given region. Find the potential difference. Find the potential difference between A and B. So
sir,
if you
potential difference between
A and B, so you can see clearly the shortest distance between these 2 points considered in the electric field is of course 1 meter. This is how I can show it. And you know, VA minus VB will be minus EDR or DX. So it is minus 10 into 1, minus 10 volts. They are simple, but students will be missing the clarity.
Completed, sir.
Okay.
Sir, 1 second.
Hmm.
Completed, sir.
Okay. Next is, of course, standard question present in many books. Copied from, of course, Irudau. There are two thin rings each of radius r, each of radius r, which are coaxial with charges q and minus q. Find the potential difference between the centers of the rings. Find the potential difference between centers of the rings. Separated by the distance a. Separated by the distance a. Very simple. First, we have to consider the potential at B due to both the rings, then potential at A, then VA minus VB. So, the required potential difference is VA minus VB. This distance will be, of course, R square plus A square under root. The potential due to the first conducting ring VA will be first due to the first ring at the point A, it is Q by 4 pi epsilon 0 R. Superposition principle V1 plus V2. So next is due to the second charge minus Q by distance of the center of the distance of the first ring from the center of the second ring, 4 pi epsilon 0
into root r square
r
plus
square plus a square to the power of 1 by 2. So we can take out q by 4 pi epsilon 0, 1 minus 1 by r square plus a square to the power of 1 by 2.
Sir, 1 by
Sir,
r
1 by
minus.
r
Sir.
minus.
Huh?
1 by
1 by
r
r
minus
minus.
1 by root r square
Yeah,
plus
yes,
s square.
yes. Similarly, VB, it is minus q by 4 pi epsilon 0 r plus q by 4 pi epsilon 0 into r square plus a square to the power of 1 by 2. So in the similar manner, it becomes q by 4 pi epsilon 0 into 1 by r square plus a square to the power of 1 by 2 minus 1 by r. So now VA minus VB. So it is 1 by r minus of minus 1 by r. So it will be 2q by 4 pi epsilon 0 r minus 2q by 4 pi epsilon 0. Yeah, r square, if you take common, it becomes r into 1 plus a square by r square to the power of 1 by 2. So finally, I will be getting it as VA minus VB is 2q by 4 pi epsilon 0 r into 1 minus 1 by root of 1 plus a square by r square. That's all. In fact, it is from Iridov, but many books have presented. Good question. Completed, huh?
Yes, sir.
Yes, sir.
Okay. Next. This is also from Iridov. There is infinitely long straight thread. There is infinitely long straight thread with the linear density of 0.4 microcoulomb meter inverse, centimeter inverse, sorry. Microcoulomb per centimeter. Calculate the potential difference between the 2 points A and B. Calculate the potential difference between A and B. If B is removed, two times farther from the thread. If B is removed two times farther from the thread than that of A. So you can assume that XB is equal to 2x1 or 2xa, or RB is equal to R2 is equal to 2R. Anyway, you can put it. So first step, already we discussed it. Gauss law is equal to lambda by 2 pi epsilon 0 R. And from that, you know, work done is, of course, minus E bar dot dr bar. So it will be minus of it is moved eta is equal 2 times farther from the thread. So R1, R2 into lambda by 2 pi epsilon 0 into dr by r. So we will be getting it as lambda by 2 pi epsilon 0 into log of eta. Then the third step, potential difference is work done on a unit positive charge, that is, here it's a unit positive charge, we have to assume. So we'll be getting it as delta V lambda by 2 pi epsilon 0 into log of eta. So in fact, formula importance, I made it numerical. So it is lambda 0.4 into 10 to the power of minus 6 by 10 to the power of minus 2 2 by 8 pi epsilon 0. No, 4 by 8 pi epsilon 0. You want 2 pi epsilon 0, so 2 by 4 pi epsilon 0. Yes. Means 2 into, yeah, 9 into 10 to the power of 9. Am I right?
Yes, sir.
Into 2.3 log 2 to the base 10. Please check. Correct?
Yes, sir.
So this is 9 plus 2, 11 minus 7. So 10 to the power of 4. So I am left with 18 into 10 to the power of 4 into 0.6990 standard value. Even nuclear physics also we used this many times. So 18 into 10 to the power of 4 into 0.69. How much?
12.42.
4 is also there, right? We forgot it. Should be 72, right?
Yes, sir.
Oh. Ramakrishna, sleeping. Ramakrishna,
Sir?
sleeping, right?
No, sir.
I forgot 4. 18, even Kushik also, I think you are not active. Morning, you should be very active. I forgot to multiply with 4. 18 into 4, 72 into 10 to the power of 4 into 0.69. If it is 0.7, nearly,
Sir, almost 50.4, sir. I
yeah,
took
that's what I'm trying
0.7.
to tell, 50 kilovolts. Nearly it comes out to be 5. So 50 kilovolts is the potential difference. Okay.
Sir, I think
One
500 kilovolts, sir.
More.
72 into 0.7.
70 into 0.7. How much?
50, sir.
Okay. Yeah.
500.
Yes. 500 kilovolts. Okay.
Yes, sir.
Yes, sir.
Formula importance. Yeah. What are the potential and electric field strength? Due to a circular charged disk,
Sir, can you repeat once again?
what are the potential and circular charged disk at a point on its axis at a distance L from its center. If the disk has a uniform charge density sigma, so this is the radius. We assume a small element of the disk of thickness dx and radius say x. Then, and the distance of this point will become root of x square plus L square. The charge due to this circular strip, so it will be sigma into 2 pi x dx. Correct only?
Yes, sir.
So the potential due to this strip at the point will be dq by 4 pi epsilon 0 into root of x square plus L square. So I get, this is the first step. So from that we are writing dV. So it becomes sigma into 2 pi x dx by 4 pi epsilon 0. dq is nothing but surface charge density multiplied by area of that circular strip considered. So that's a concept. So 4 pi epsilon 0 into root of x square plus L square. So you have to, if you want the potential, then it is integral dV. Limits are from 0 to L, because he has given the distance OP as L. So we will be getting it as sigma L by 2 epsilon 0 into 1 plus R by L whole square minus 1.
Sir, we should change the x value, no, sir. X from 0 to R, no, sir.
That's what we did, na? Not R. R means on the surface you will get. You wanted at a point on the axis passing through the center of the disk and perpendicular to the plane at a distance L. Okay?
Yes, sir.
So that's the potential. And if L tends to 0, then we will be getting V naught is equal to sigma R by 2 epsilon 0. And E, it is minus dV by dl. So this implies E is equal to sigma by 2 epsilon 0 into 1 minus 1 by root of 1 plus r by L whole square. And here also, if L tends to 0, E naught sigma by 2 epsilon 0. Okay.
Yes, sir.
Yes, sir.
Next. The potential as a function of distance is given by, we did already another one. The potential as a function of distance is given by V is equal to minus AX cube plus B. Find the space charge density as a function of X. See, first of all, E is equal to minus dV by dx. Simple concept only instead of asking field, he asked the space charge density. Now, dou E by dou x, because it is only the function of x. So, space charge density in terms as a function of x by epsilon 0. So, space charge density as a function of x will become epsilon 0 into dou E by dou x. So, we will be getting it as 6a epsilon 0 into x. Yeah, we'll continue few more problems tomorrow. Completed, huh?
Yes, sir.
Yes, sir.
So tomorrow we'll continue a few more problems. Today all questions are from Iridov. Tomorrow we'll do mixed. Few from Iridov and few from other series. Okay?
Okay,
Yes,
sir.
sir.
Right. We'll continue tomorrow. Bye.
Thank you, sir.
Ramakrishna,
Thank you, sir.
in time.
Yes, sir.
Vivek Sai, please come in
Okay, sir.
so that
Okay.
you won't miss anything.
Yes, sir.
Okay.